Hello, welcome to today's presentation. You'll see on the screen that Ton van Gronderbeek is making this presentation, but actually Ton couldn't make it today. So I'm stepping in for him. My name is Ian Knight. I'm the director of Enluse BV, and I'm also a shareholder on Lubritek. Ton is also a shareholder in Enluse. So we really are sister companies, and we both work on the concept of lubrication reliability, which is what this presentation is all today. So with that, let's get into it. What is lubrication reliability? Well, step by step. If we think about the reliability of a component, it's a machine, it's generally referred to as asset reliability. This is the reliability of a machine or a component. A component, of course, can be a bearing. So we could say bearing reliability or component reliability, but the reliability of that really equals the quality of the lubrication process or the product itself. And quality lubrication, and we talk about it as a concept, the excellence of also equals the 6 lubrication rights. Now we'll get into the lubrication rights a little bit later, but these are a set of questions that one would ask about any particular lubrication point in the machine. And if you answer no to any one of those points, then you have a problem with your lubrication reliability. But we'll cover that a little further on. The implementation of the 6 lubrication rights is really the foundation of lubrication reliability. So if you answer yes to all of those 6 questions, then you have a good lubrication reliability strategy in place. And lubrication reliability really covers 7 fundamental steps, 7 things that one needs to do to ensure that, again, we say yes to all of the 6 lubrication rights. The focus fundament, and this is the basis of the whole thing, it's the storage of the lube, it's the conditioning of the lube, it's how we dispense the lube, and how we monitor the process. Now, if those steps are not in place, all of the other 6 steps in the whole 10-step fundamental process will not work. So, a little bit of facts and physics. Bearing failures are really the heart of the rotation machine. If the bearing fails or is disturbed in performance in any way, so does your machine fail. And we know from statistical analysis and work over many, many years, and I myself worked in SKF for 35 years, that 60% of bearing failures are lubrication related. And there are many things under that concept, lubrication related, but we'll cover that a little bit more as we get further into the presentation. The lubricant is really the lifeblood of the bearing. It reduces metal to metal friction because it separates the rolling elements or the moving components in a bearing or in a machine. And in separation, it reduces surface wear. So it minimizes surface to surface touching. And as a result, a reduction in wear is an increase in component life. The key to the whole thing is really the lubrication film thickness. In order to have a good bearing operation, we need to separate those components with a lubricant. This is called the lubrication film thickness. And typically, it's very small. It's 1 to 3 microns. So it is critical. Clean and pure, uncontaminated lubricants are critical for this application. And this is what we're trying to do with the concept of lubrication reliability. We're trying to make sure we have a very good lubrication film thickness. Now let's look a little bit about the effect of wear or contamination in an oil to bearing life. Bearing contamination and its effect on life was well known back in the 80s, and a lot of work was being done then by a lot of the big companies of it. I myself was working in Sweden at that time at SKF and was quite familiar with all of the research work that was going on of what they call the SKF New Life theory. And they were trying to find a way to build into the life calculation of the bearing a parameter that considered the contamination level within the lubricant. So if you knew the type of contaminants and the size and amount of those contaminants, you could factor these into the equation of bearing life. It could go down or it could go up. Now, ISO also got involved in this, and they started to develop a strategy which is today known as the standard ISO 4406, where they measured the number of components in 3 different size groups, in this case 3, 5, and 15 micron, in 100 milliliters of oil. And with each of those amount of quantity, they are given a code. So if you look at the graph here, and on the left-hand side, we have a ISO 4406 code of 221813. Now, this could be a very normal operating contaminant level within a gearbox. And I know many new lubricants are this dirty. But if we were able to increase the cleanliness level to an ISO code as 16128, which, by the way, would be a best practice for a hydraulic system, we're looking at a 4 times increase in life. So the mean time between failures in hours would increase by a factor of 4. Another very interesting statistic is some research work done by Dr. McPherson from Westland Helicopters. Here, Dr. McPherson looked at millions of cycles to fatigue failure of a bearing, and he related those to the filter rating element size filtering the oil. So this is the particle size in micron where the filter element was a beta 200. Bottom line to this, if you took a 40 micron filter, which I refer to as a rock catcher, you can see on the scale of infinite life, we're not going to get much life. On the other side of the scale, if we're running with a 3 micron filter element, we can have infinite life. And what this is really saying is that if the bearing has a contaminant level lower than the lubrication film thickness in the bearing will not wear and has an ultimate life. Now, this is confirmed by this graphic that I made. If you take this cross section of a ball and an inner ring, you can see the load zone. This load zone really is separated by the lubrication film thickness, which is very small. So small that if you pluck one piece of hair out of your head and put it under a microscope, and with surgical tools we're able to cut it 20 times slice wise, that's the thickness of the lubrication film thickness in a bearing. So think about this. If you've got a piece of silicon sand floating around the warehouse or the factory or the store, and it's 20 microns in diameter, and you can't see 20 microns, it would be, and that goes through the bearing, it would have the same sort of concept if you drove your car over a rock about 1 meter diameter. This is how wear really starts. So the 6 lubrication rights, let me load them all first. Again, I come back to the point. If you ask this question for any application, you ask the question, is it the right lube? Was it selected correctly? Are we adding it at the right time? Is it the reschedule? Is the reload area or the replenishment area? Is it the right amount of quantity? Because we don't want too much or we don't want too less. Is it the right machine that we're putting into it? Is it well labeled? and making sure that we've got the right lube in it? Are we adding it in the right way so that we're not contaminating the oil in the process, or we're making problems with the environment, spilling the oil? And are we keeping the oil in the best practice condition? So if we're answering yes to all of these questions, and these are the questions we should ask ourselves when we're planning on any lubrication activity for a machine or a component. If you answer yes, you're on the right track. You've certainly got a lubrication strategy in place. If you answer no, there's a break in the chain somewhere. And we need to go back and ask the question, why? Here is a not untypical application of I think it's a steel mill in Asia where Tom got this one. You can see the lube barrels outside, damaged, dirty, contaminated, dispensing equipment, hoses also contaminated. This we don't want. This is really what causes contaminant going into the machine. With this, you're only adding dirty oil to the machine. So how do we do this? How do we ensure that we have the 6 lubrication rights implemented in a structured and organized way? It's not easy. The key to this whole thing is strategy. The answer, lubrication reliability. And Tom has been quite a leader in the effort of trying to define exactly what is lubrication reliability when it comes to equipment reliability. So let me load all these 10, and then I'll come back to them one after the other. Here you can see 1, lubrication assessment, training, education, organization and planning, oil analysis, grease lubrication, contamination control, and then the bottom foundation, oil distribution or transfer, lubricant storage, monitoring identification, cleanliness control. These are the foundation. If any one of these foundations are not in place, the rest of this just won't work. For example, if you have a lube bay and you put in a well-documented lube bay, which is lubrication reliability compliant, it considers the oil transfer and distribution. It considers that the oil needs to be cleaned in the process, and it has all the mechanisms in place to ensure that only clean oil goes out of the lube room. So just by looking at the lubrication storage in its own right is the first step to achieve the whole 10 fundamentals of lubrication reliability. Let's take the first one. What we need to do when we do an assessment, and we do a lot of them, we need to know where we are, because if we don't know where we are, we don't know how to get to where we want to be. So what we need to do is, what are we doing wrong? What is it that we need to do improve? What are we doing right? And when we look at a strategy, we generally look at 6 levels, and they are the strategy, cleanliness, contamination control, database, and reporting, lubrication knowledge and application. And then we also look at the environmental and safety component and the supply component to see what our suppliers are doing. And we also know that when a company embarks on a lubrication reliability strategy, they go through an evolution of stages of it. And it generally starts with getting the basics in place. Then it's how to build the processes, looking again at each one of these, and then how to do proactive maintenance. And proactive maintenance is the component where we use oil analysis to determine a problem. Then we find the cause of the problem, we eliminate the problem, preventing it from rehappening. And finally, the lubrication process becomes an integral and seamless component of the asset reliability strategy in the company. Here is the 4 key components of it: lubrication strategy, cleanliness, contamination control, database management reporting, and lubrication knowledge and application. And looking at the levels, the basic lubrication processes, proactive lubrication, and asset efficiency culture. So if we just look at a couple of the key benchmarks, the basics, we need to have dedicated resources. We need to have a lube room standards in place. And again, I come back to the point, this is a foundation of it. And we also need to have a database in existence because we need to know what to do, when to do, how much to do, etc., etc., etc. The 6 lubrication rights. And this won't happen unless the company considers the lubrication reliability investment as an investment in uptime and not as a cost scenario. And if we go the other end of the scale of a true asset efficiency culture, we need key performance indicators on the lubrication effect to the overall equipment reliability. We need overall plant cleanliness measurements. What is the ISO 4406 standard for gearboxes for hydraulic systems, for example? It needs to be integrated and seamless to a computerized maintenance management system, and the activity needs to be measured as to how effective it is to the total plant maintenance and reliability structure. Training is critical, and it was, I guess it goes nearly 20 years ago, 15 to 20 years ago, the International Council of Machinery Lubrication was formed, made up with a lot of interested, knowledgeable people about lubrication. And they put together a training course, and that training course is run all over the world today, and it certifies people in different levels: a lubrication technician, a lubrication analyst, a lubrication engineer, and these are available. And if a company is really going to do lubrication reliability, someone needs to be certified in it, if not more than one. Organization and planning, critical. Many companies today try and do their lubrication in their computerized maintenance management system, but I can tell you it doesn't go down in enough detail. You need, in many cases, a dedicated lubrication software, and they are available as standalone or online, or they can come part of a free issue with a supplier contract. All have upsides and all have downsides, but the point is it needs to be considered. Oil analysis program, again, based on ISO 4406. Here's a typical chart. Most companies that are doing it are providing reporting data. And from this, you can see the growth or decrease of certain problem areas. And also you can have graphs. It tells you chemically how good the oil is and what are the contaminants within the oil. But often, and we see this many, many times, that a company may have a contract with a supplier who provides oil analysis reports, but they end up in a binder or a cupboard and they more than not are not even read. So you don't apply them to the machine. Grease lubrication, again, very, very important. Biggest percentage of lubricated positions in a company are grease lubricated. Again, we supply color-coded grease guns in all different forms. Electric grease guns with digital meters. They can be single-point lubricators or multi-point lubricators. And measuring the ultrasonics is important when lubricating, because when you have a low lube film, you get asperities touching, and this generates ultrasonic noise. When the grease hits a bearing and the elements are separated, the noise goes down. So there are companies available today that provide this data. Contamination control, and this is really stopping contaminants getting into the machine and cleaning up the contaminants in the machine. Best practice on the cleanup is the oil safe filtration cart. It is environmentally friendly and it is technically sound. from loss of, to make sure that only clean air gets into the machine, we use desiccant breathers. The desiccant gel will absorb the moisture as the application breathes. And you can imagine a hydraulic system when the cylinders go in and out, push air in and out of the capacity. And if you don't have a breather, you're just contaminating the oil. Oil transfer, these are very, very typical pictures of oil. See it often, open jugs, here, you can see them, open drums being exposed to the atmosphere. Remember, you can't see 20 microns, and 20 microns is 7 times bigger than the lube film. So contaminants are going to get into the bearing. So we want to eliminate, not to mention the environmental impact if we spill something. Oil Safe is undoubtedly the best product on the market for distribution. It's safe, it's clean, it's very efficient, very user-friendly, it's very ergonomic to handle. It's multicolored, so we have one color per lube, and there are 10 different colors on Oil Safe. It's contamination free, it will not spill, as you can see, the one held upside down here, and it's fully sealable. It is undoubtedly the best practice in lubrication management in distribution. Here is some typical examples of storage. Open grease containers, very dirty lube room, open drums. I have to tell a little story here. This one here, the second from the right on the bottom, that shell drum of grease there, this is in a little storeroom in a food company. And this is the area where the workers go at the morning break and afternoon break to have their cigarette. They were butting their cigarettes in this drum. Can you imagine the effect it has on the lube? And look at this one, messy, dirty, grease nipples where dirt can accumulate. Next time you put the grease gun on there, you just pump it into the bearing. They're not labeled, so we don't know what grease goes in. We hope it's only one grease, but this is pretty typical. So let's look at this. Here we have a situation where if you had drums outside, and we don't have a lot of time for talking about this, but the problem is if you store drums outside and there is rain and moisture, water accumulates on the top. Eventually, with moving temperatures, you'll get condensation. You'll eventually end up with water inside the oil. The longer it sits outside, the more oil, the more water will accumulate. Water is a killer for oil and a killer for bearings. So in cleanliness and contamination control in storage areas, we need closed circuits. We need to filter the oil. And why should we filter new oil? Simply because new oil is not clean. It is more often than not dirtier than the standard that we have set for a cleanliness oil in our machine. So we need to increase the cleanliness, and we have to guarantee that we don't have cross-contamination. One of the biggest effects on affecting the viscosity in a lube is because we've mixed the lubes. Okay, and management, we need to control how much we send. We need to have good identification. We need to manage the stock so it doesn't age. And the measurement criteria for the cleanliness is ISO 4406. And of course, we need to make sure that the room itself is normal storage temperatures. It's a dry environment. We don't want to add moisture to the application, and it must meet all the restrictions, regulations, for example, for oil retention, for spillage, fire resistance, and the plant may be ATEX certified, so the room has to be separated. Here's some typical systems we sell at Lubritech. We make these lubristations, which are modified 20 and 40-foot containers. The floor is steel, it's welded in, and it becomes a spill protection bund in its own right. They can have all variations, insulated, air conditioned, they're all. They can have heating, lights, power, and air. And in these systems, we use pneumatic pumps. You can see here on the right-hand side, we have an adapter in the drum. We pull the oil out of the drum. It has a desiccant breather on, so when the oil goes down, only clean, dry air goes in. So the oil then goes up to the pump. The pump pumps the oil through the filter, and it can go, if you turn this tap on, it can go back into the drum, so you can filter over the drum, clean up the new oil, or you turn the tap the other way, and then you feed the oil to the dispensing bar, which has a tap and a consumption meter. A pretty standard system. We've sold many of these in the market, Europe, and quite a few also into Asia. We also have facilities for managing grease. And this is an innovative product that we developed and then sold to the Oil Safe organization, the Luster system. It does all this on the right, contained in one application. They're available in 250 litre units or 500 litre units. And then, of course, oil analysis. Oops, let me go back one. We have all the tools for this. We have not only the monitoring, the extraction tools and the bottles, but we all have sight glasses. They can be three-dimensional sight glasses. They can be sampling ports, drain ports, fill level. We have all of the products enabling us to do good oil analysis, both visually and chemically. And again, from the contamination level, ISO 4406 is key. Identification is critical, and we like to recommend for one lube. Here is a small hydraulic system on a cardboard corrugator cutting machine. We have a colored, a green oil safe can, identification on the can, a green label on the fill point. So the machine is labeled, the oil can is labeled, and so is the storage. In this case, the Luster system is blue with a blue oil can, but it's all related to a color-coded chart that is set up. So we have a lube room can be anything up to 10 or 12 lubes. We need a different identification for each lube. And we don't want mixing because of different chemistries, different compatibilities, different viscosities, and we certainly don't want to mix that. And we need to meet all the standards, both environmental standards and internal standards. And cleanliness control. Next one. We stress here clean, clean, clean environment. It's a clinical process. And this room we see is not a lube room, but it's a clean room. And this is what we should be aiming for. Again, 5S TPM type strategies are applicable here to help us on the cleanliness control and the sustainability of the cleanliness. We have to meet and recognize that we have different environments. Here in the center picture is a hydraulic system outside. You can see the dust and dirt. It has a guardian breather. In addition to that, it has a filtering system on top of the guardian breather. The oil in this hydraulic system is protected and clean. And this is a typical lube room that we've installed using the Luster system. It's a rapeseed milling organization. And as you can see, it has 7 different lubes and all color coordinated. It's air conditioned, it's sealed, it's clean, it's perfect. And of course, process of continuous improvement is perfect. Oh, and one final point. When you start implementing a lubrication reliability strategy, you turn the old lubricator into a very happy man, because all of a sudden you've put quality into the process of the work. Important point. So, conclusions. Lubricants should be well treated. They are extremely important, and they are the component that will eliminate or reduce wear and prolong bearing life. Machine reliability is dependent on this lubrication. And lubrication reliability is your strategy. And the strategy is 10 fundamental keys. Contamination control is what we need to look at, starting with the lube bank. Storage, conditioning, and transfer are the priorities. Remember the foundation of the triangle of the 10 steps. And the need for best practice, equipment and management put into place will generate a good and high return on investment. That's it. I hope I've been able to present it as Ton would have done. If not, I do apologize to Ton. I would say that Ton is available for answering the questions after this is running in the show, and he will be on the Enluse stand for the whole time. So please feel free to reach out to him. And now we're also open to take any questions. Thank you.